Hello and welcome to this video in the wave series. In this one we are going to look at the wave equation. So it's quite a maths heavy topic is this one. We're going to look at the formula and we're going to look at where this formula comes from. Then we're going to practice using it just in simple terms. So just going to be substituting in values and just practicing. I'm going to show you a few models and give you a chance to get used to and happy at using this formula. Then we'll do something a little bit more difficult. We'll take the formula and we'll put in some values and we'll rearrange and manipulate the formula in order to find some values that aren't initially the subject. And then what we're going to do is we're going to try and put together quite a few things that we've learned from the previous videos. So we're going to calculate the wave speed of a wave by looking at a wave diagram. And in order to be able to do that, you have to be able to know a lot of the things that we've done previously. So, as always, we're going to start with some recall. On the screen will be a grid with quite a few previous things. This time I have color-coded it as to how long ago it should have been since you learnt that content. So what I want you to do is to pause the screen, answer those questions, unpause them when you're ready, and then check them before we start the new stuff. Okay, good luck. Before we look at the equation that allows you to calculate the speed of the wave, I'm going to show you an example of a situation where waves can travel at different speeds, and hopefully you'll be familiar with this one. So I've drawn a cloud, and in this cloud I'm going to draw a lightning bolt coming out of it, because sometimes when you get a buildup of static electricity in clouds, you can get a lightning bolt produced. And when you've been talking before about lightning, you might not just talk about lightning, you might talk about thunder and lightning. People often think that they're two different things. Well, they're not. They're just two different ways of experiencing the lightning. And it's because different waves are given off when the lightning happens. So you get a light wave, all right, which travels from the lightning bolt into your eye. And the bit that you see that is light is what we call the lightning. So that is light. That's a light wave. And there's another type of wave, which is what we call the thunder part of it. And that is where the sound travels from the lightning bolt into your ear. And that's a sound wave. And that's what we call the thunder. Now, the light waves and the sound waves both come from the lightning bolt, but they don't travel at the same speed. So unless you are in direct danger of getting hit by the lightning bolt, you are not going to hear and see the lightning bolt at the same time. What normally happens is when you're a fair distance away from the lightning, is you will see it first. And that's because light waves travel a lot faster than sound waves. And after a couple of seconds, you'll then hear it. And you'll hear the thunder roar, like the clap of the thunder. And that's because the sound waves travel slower. So we've got the light is traveling faster, and the sound is traveling slower. And we can actually use this because you can work out how far away the lightning is roughly by, as soon as you see the lightning bolt, you just count. And the longer it takes to hear the thunder, the further away it is. So if you can only count for a couple of seconds, that lightning is actually quite close to you. Whereas if you can count for a good 10 to 20 seconds until you hear the thunder, it's probably it's far away. So in this video, we're going to look at using the wave equation, and we're going to calculate the speed of light, and we're going to also calculate the speed of sound so that you can compare and you can see how much faster light is than sound. So let's take a look at the formula. First off, we're going to write it in words. So it says that the wave speed, so that's just the speed of the wave, is equal to Now, this is a term that we've just looked at previously. So this is frequency. So remember, frequency is the number of waves per second, and frequency times by wavelength. And wavelength is the length of the wave in meters. So we also need to write it in symbols, because if we write this out every single time, it's just going to take a lot longer than it needs to. So in science, we use symbols in order to represent words. So wave speed, we're going to use V. That stands for velocity. We're going to carry the equal sign directly underneath. And for frequency, we've used an F before. So it's sort of an italic F. And for wavelength, we're going to use the symbol that we've used previously, which is this lambda symbol. So we've got wave speed equals frequency times wavelength. And this means exactly the same thing. It's just going to be a lot faster to write this out. And the last thing you need to know is the units, because in some of these questions later, I'm going to ask you to convert, because we always need to make sure that we are in what we call our standard units. We sometimes see them called SI units. They're standard international units, the ones that the scientific community have agreed on using. So the wave speed, any speed in science, needs to be in meters per second. Frequency. Frequency is always measured in hertz. Hz. And the wavelength, well, all lengths in science are measured in meters. So wavelength is just meters. Okay. In this section of the video, we are going to practice using our formula. So whenever you have to solve an equation, the first thing you always do is you just read the equation straight through. So a sound wave has a wavelength of 17.15 meters and a frequency of 20 hertz. Calculate the speed of sound. So once you've read the equation, what we now do is we read it again, but we're looking to extract from it. So we want to extract any numbers, and we also want to figure out what the question is asking us to find. So the first thing you do is you look at what the question is asking you to find. So this says calculate the speed of sound. So it wants us to calculate the speed. So I'm going to put a box around that term. And the speed in the equation, remember, was the symbol V for velocity. So the sound wave has a wavelength of 17.15 meters. That's another number, so we're going to underline it. And we look at the unit. Which part of this equation is in meters? Well, meters is wavelength, but it also tells you there. And remember, we use this symbol, lambda, to represent wavelength. And a frequency of 20 hertz. Now, that's actually the lowest frequency of human hearing. Human hearing is 20 to 20,000 hertz, or 20 kilohertz. So this is the lowest. And hertz, that must be the frequency, and frequency we use an F. So once we've extracted our data, we're going to list them down the side here, because we want to make it really, really clear when we're doing our calculations where these numbers are coming from. So we can just write them down. So we've got wavelength here. So the wavelength is 17.15, and we put the unit in meters because we need to check it's in the right unit. The frequency is 20 hertz, and the speed is unknown. So we'll put a question mark in there, but we should put the unit as well. So anything that's speed, remember, our answer will be in meters per second. So we might as well put that in there so that we can check it when we get our answer. Okay, so now we've extracted the data. The next thing we need to do is we need to ask ourselves, are these units correct? So is wavelength in meters? Well, yes, it is. So that unit is correct. Frequency in hertz, yep, that's correct. And velocity in meters per second, yep, that's correct. So we don't need to do any converting. These numbers are absolutely fine. So once we've got this, the thing we do now is we write the equation in symbols that links all of these values together. So we've got a wavelength, we've got a frequency and a velocity, and there's only one equation that links these things, and it's V, so velocity. And we're going to spread this out, so we might as well use all of the space, equals frequency times by wavelength. Now, once we've got our equation, what we're going to do is we're going to substitute. So we're going to substitute our values straight into there. So rather than having V, we go down to here and we see what V is. Well, V is currently question mark. So we could put a question mark, but it's easier to keep it as V. So we're going to keep that as V. Follow down, equal sign. Now, what does the F symbol? Now, F has been replaced by this 20 hertz. And we don't need to put the units in. The units, we just need to have checked that they are right. So we're just going to write 20. Follow down, multiplication. And rather than lambda, we are going to put in 17.15. Again, don't need the units. Okay. So what we need to do now is we need to check that the thing that we are trying to calculate is actually the subject. So we are trying to calculate the speed, V. Is that the subject? That means that it's on its own on one side of the equal sign. And yes, it is. So that means that we don't have to rearrange. We can just go and we can combine, we can just calculate these numbers. So that's what we're going to do now. So we're just going to do 20 times by 17.15, and that will give us V. So V will equal, now what I'd like you to do is I'd like you to pause the video now, and I'd like you to try this sum for yourself, and then come back to the video and I will carry on and I'll solve it for you. Okay, so you get your calculator. So we've got our sum, which is 20 times 17.15. Oh, better turn it on. 20 times 17.15. That's right, it's really important to check your calculation. 17.15 equals, and we get 343. Now we aren't finished yet, because what we have to do is we have to check that we've got the right number of significant figures. Now we aren't told anything here, so that's fine. We can just leave it as this. If we aren't told anything, what I would always suggest is you do 2 decimal places, but there are no decimal places here, so that's absolutely fine. And the last thing we need to do is you need to make sure that you've got some units on here, because otherwise it's 343, but you're not telling the examiner what. It could be 343 lollipops for all you know. So 343. Now, what are the units of velocity? Well, that would be meters per second. So 343 meters per second. Underline it for the examiner. Tell them this is my answer. One more very similar problem. So remember, read the question. A wave has a frequency of 100 hertz. A student measures the wavelength of the wave as 50 centimeters. Calculate the speed of the wave. Next step, to extract the data. So we're going to underline any numbers and their units. So the first thing we've got is 100 hertz. Hertz is frequency. So that one's frequency. A student measures the wavelength of the wave as 50 centimeters. Now, this is a bit of a tricky one because centimeters are not the units of length, right? But they are a unit of length. So that is a length. So the only thing it can be is wavelength. So it's going to be wavelength, but we've got to convert that. So 50 centimeters, we have to convert that into meters. We'll do that again. We'll do that in a second, but let's just put an asterisk there so we know we've got to do something. Now, what are we actually trying to find? We're trying to find the speed. So we're going to put a box around that. We're trying to find the speed. Now let's list what we've got and we'll convert this. So we've got V is unknown. So we don't know that, but speed is always going to be in meters per second. And because that's in meters, this can't be in centimeters. Frequency, that is 100 hertz, and the wavelength was measured at 50 centimeters. And this is why it's so important to write these units so that we can check them. So now we've got everything listed down. We can ignore the question really because everything's here now. Let's convert. So let's check the units. Meters per second, that one's right. Hertz for frequency, that's right. Centimeters for wavelength, that is not right. That needs to be converted to meters. So how do we convert 50 centimeters to meters? I'll do this in a different color. Well, in a meter ruler, there are 100 centimeters. Now, we want to think about this. If we've got 50 out of 100, have we got a whole one? No, we haven't. So our number is going to be less. So what we do to get centimeters to meters is we divide by 100, because there are 100 centimeters in 1 meter. So if you do on your calculator 50 divided by 100, so do it now. 50 divided by 100, and you'll get a half. Just press the SD button and you should get 0.5. So what we've actually got is 0.5 meters. Now what I like to do is I like to get rid of this. So let's put a line for it so that I don't accidentally still use that in my formula. But I'm making sure I leave this because I'm showing the examiner, look, I knew to convert, and that's a mark. That's always going to give you 1 mark in an exam, so you should feel good about yourself already. So once we've we've extracted, we've converted, we now need to write our formula. So V equals frequency times the wavelength. Okay, once we've got the formula, we need to substitute our values in. So V is unknown, so that stays as V. If at any point you think you know exactly what to do, pause this video, and get yourself a final answer and then come back to it. All right, you don't have to watch me through all the way if you think you know what to do. If you come back to me and you've got the wrong answer, then watch it again just to check. So V equals, F is replaced 100, multiplication sign, and our wavelength is now not 50 centimeters, it's now 0.5. Remember, we're not putting the units in. Okay, now if that was the help you needed, and now you think you know what to do, pause it and have a go. V equals 100 times 0.5, we'll do that on the calculator. 100 times 0.5 equals 50. So V equals 50. Are there anything about significant figures? No, there's not. So therefore, this is fine. Is it more than 2 decimal places? No, it's not. So we'll leave it as 50. And the last thing we need is units. Okay, so 50 meters per second. Underline it. Tell the examiner, this is my answer. Okay. What I'm going to do now is I'm going to put some practice questions up for you. And I'd like you to have a go at those. I'll do a little bit of work on the first couple just to guide you a little bit. And then there'll be some that you can just practice all the way from scratch on your own. Once you are confident, then you can move on to the next part of the video where we're going to look at rearranging. In this part of the video, we are going to look again at using calculations, but in a slightly more complex way. So again, we'll use the same steps. So we'll read the question. A sound wave is oscillating at the highest frequency a human can detect. That's 20 kilohertz. That's 20,000 hertz. Calculate the wavelength of the sound. So again, let's underline any values, so any numbers that we see. Okay, so the first one we see is this, 20 kilohertz. Now, hertz is frequency, so this is going to be our frequency, but it's not just in hertz, it's in kilohertz. I'm going to put an apostrophe so that I know I need to rearrange. What am I trying to find? Well, it wants me to calculate the wavelength. So there we go. Okay, and wavelength is here. So that's all the information we can get. Let's write down what we've got. So we've got the frequency, and we know that that is 20 kilohertz, and we're trying to find wavelength. We don't know that at the moment, but we do know that wavelength should be in meters. And the other thing we'll need in this formula, frequency, wavelength, is we're going to need the speed. We're going to need velocity, but the question doesn't tell us that. However, I've done this on purpose because in the previous part of the video, we calculated the speed of a sound wave, This is an example of a linked question. This might be the second part of a question. The first part of the question might get you to calculate the sound wave. And in this second part, you might be asked to then use that information to calculate a sound wave with a different frequency and what that wavelength must be. So we got 343 meters per second as the velocity. Okay, you wouldn't be expected to remember that. It's a good thing to know, but you wouldn't be expected to remember that. It's just I thought I'd put that in so that you can remember that these equations all link together. So we've got our data extracted. Next we need to do is we need to check if they're in the right units. So kilohertz for frequency. Nope, that is not in the right unit. So we are going to have to convert, and we're going to have to turn that into hertz. Now kilo means you've got 1,000, like kilometer is 1,000 meters, kilogram is 1,000 grams. So this is 1,000 hertz. So we've got 20,000 hertz. So all we do is we multiply our 20 by 1,000, okay, which will give us our conversion. So have a go at that now. Quite straightforward. We don't need a calculator for this one, but it's always good practice in science. You've got it available, so always use it just to check. So 20 times by 1,000 equals 20,000. So 20 hertz. Again, that's the one we want to use in our equations. So we're going to put a cross through that so that we don't accidentally use it. But we're not scribbling it out because we're showing the examiner what we've done. This one, we don't know, it is going to be in meters. And this one is in meters per second. So that is the correct unit for velocity. So all the conversions are right. So we've extracted, we have converted. The next thing we do is we write our formula. I'm going to write it here. So V equals frequency times wavelength. Now we're going to substitute in. So it's exactly the same steps as we were doing previously. So V, do we know what V is? Ah, yes, we do. It's 343. So 343 equals frequency, F. Yep, we know that is 20,000. And we're going to multiply that by the wavelength, which we currently don't know. So we're going to leave that as wavelength. Okay, so now we need to ask ourselves the question, is the thing that we want, is the subject on its own on one side of the equal sign? Now the subject, the thing that we want, the question mark, is the wavelength. Well, that isn't on its own because that is currently being multiplied by 20,000. Because remember, maths works forwards and backwards. It's not like in written language where we read in English from left to right. Maths can work both ways. It's orders of operations. So this is, so we are going to have to get this on its own. So we're going to have to rearrange. So let's do that. Now currently, what we want, the wavelength, is being multiplied by 20,000. So we do the opposite to get rid of 20,000 to leave it on its own. So the opposite of multiplication is to divide, and it's divide by 20,000 because 20,000 goes into 20,000 one time, which would cancel out to be 1 times by whatever the wavelength is, and 1 times anything is itself. So that will get rid of those. But if we do an operation to one side, we've got to do it to the other side too. So we're going to divide that side also by 20,000. So now we should combine. We should do, and so we should combine and see what we've got. So we've got 343. Now I'm going to write it as a fraction because it's I prefer to put it in the calculator that way. Divided by 20,000. So 343 divided by 20,000 equals, and now we've got 20,000 divided by 20,000, so that cancels out. So it equals the wavelength. So now the subject is on its own on one side of the equal sign. So now all we need to do is do our calculation and we should get our answer. So pause the video here, have a go at that calculation, and when you are ready, unpause it and you can check the answer. Okay, so 3, 4, 3. As I say, I'm going to use the fraction function, which is this button here. So we'll press that. Over 20,000. Okay, just always check your noughts. So thousands has 3 zeros, so 20 with 3 zeros equals, press the SD button, and it gives us 0.0715. So we're going to write that in. We can write it in here. Equals, sorry, that would equal that. So it's this side, 0.01715. Okay. Now we have got a lot of decimal places there. Now there is nothing up here that tells us significant figures. So what I would say there is if in doubt, let's go 3 significant figures. So that isn't a significant figure because it's a 0. This isn't a significant figure because it's not a 0. This is our first significant figure. So once we get to our first significant figure, we can just go 1. That's our second one. That's our third one. And this is where we're going to draw the line because we only want 3 significant figures there. So that 5, remember our rules of rounding. If it's 5 or above, it goes up. So this becomes 0.17 and this 1 becomes a 2. So our answer is 0.172. And it was whatever the units of wavelength are, well, they are meters. So we've actually just made a deliberate error there. Definitely deliberate. We'll just have a look at it. So you could see here that I've written 0.172 meters. But what I forgot to do here is I forgot to carry this 0. So my place value is all wrong. This number here that I've said 0.172 is a totally different number to 0.01715. So I've just got to correct that. So this, I'm going to put a line through it, should actually be 0. Now I have to remember that 0.017, and then as I said, this round up, so it becomes the 2, and the units for the, was it wavelength? Yeah, the wavelength are meters. So that's the correct answer. Okay, really make sure you're paying attention during these because that is such a common mistake that happens in exam questions that I've just proved to you there is really, really easy to make. Okay, we'll try one more. We are going to look at a calculation that contains standard form. So it's exactly the same thing, just that this one contains a times 10 to the power. So first thing, as always, read the question. So the speed of light is 3 times 10 to the power 8 meters per second. That's 300 million meters per second. So let's just take a little time to reflect, because when you're reading a question, you should be linking ideas to what you thought about previously. We've already calculated in this video the speed of sound as 343 meters per second. This one is 300 million meters per second. That's 1,000,000 times larger. So if we think right back to the very first concept where I showed you lightning, and I said we always see the lightning before we hear it, that's why, because light travels 1,000,000 times faster than sound. So all EM waves travel at the speed of light. We'll do more about EM waves later. They're the electromagnetic ones. And calculate the frequency, number of waves per second, of a radio wave. A radio wave is electromagnetic, so this will be its speed. That has a wavelength of 100 kilometers. So now that we've read it and we've thought about, if we linked things, let's extract the values. So first number is this one. 3 times 10 to the power 8 meters per second. Meters per second, it's going to be our velocity. All EM waves travel at the speed of light, so that's our velocity. Calculate the frequency, so this is what we're trying to find. So it wants frequency of a radio wave that has a wavelength of 100 kilometers. Now, meters are the units of wavelength, so that's going to be our wavelength. However, That's in kilometers, so we're going to need to convert that. Once we've read it, let's list our values down here. So the velocity, we can start with v equals 3 times 10 to the power 8 meters per second. We could write 300 million, but it's just going to be as easy to do this. In fact, it's going to be much more simple, because when we have lots of zeros, it's very easy to miss one out when we put them into our calculator or when we're reading our answer. And that can cost you a lot of marks. So if we can actually use standard form, it's much better. And I'll show you how to do that. Frequency, we don't know. But with frequency, it should always be in hertz. And the wavelength, we do know it's 100 kilometers. So once we've extracted, what we now need to do is we need now to look at them and to see if they need to be converted. So meters per second, that is the correct units for velocity. Hertz, yep. And kilometers, no, that one will need to be converted. So what that means, kilo means 1,000. So that means 100,000 meters. So all we need to do is just times it by 1,000. And if we do that, we'll get 100,000. But it's always worth just doing this on a calculator, just to check. You've got it, so you might as well use it. 100 times by 1,000 equals 100,000. Be very careful when you read these off. 1, 1, 2, 3, 4, 5. Always count your zeros. So 5 zeros. So 1, 3, 4, 5. 100,000. And we don't want kilometers, we want meters. So let's cross out that first unit there. So we don't actually include it, but we are showing what we've done, so our examiner can award us those marks. Once we've read the question and extracted the data, let's write the formula that links them together. So we've got V, that's a velocity, frequency, and wavelength. So V equals frequency times wavelength. Now we substitute our numbers. So V is 3 times 10 to the power 8. 3 times 10 to the power 8 equals frequency, don't know, times by wavelength, which we've now converted to 100,000 meters. What I should say is this wavelength, 100,000 meters, is actually the longest wave that you get right at the top of the electromagnetic spectrum. So this is as long as waves get. So V equals F times wavelength. So what we now need to do is we now need to look at the question and see, is the subject, the thing that we want, so the frequency, the subject? It's not, because it's being multiplied by 100,000. So we need to make it the subject. We need to get rid of this times by 100,000. In order to do that, we do the inverse, which means opposite. So it's currently times by, so we're going to divide by 100,000. Whatever we do to one side, we've got to do the other. So this side is also getting divided by 100,000. Let's combine and see what we've got. So what we've got is 3 times 10 to the power 8 divided by, now I like to write this as a fraction, divided by 100,000 equals frequency, and then this is divided and times by 100,000, so that cancels out. So this is what we're left with. 3 times 10 to the power 8 divided by 100,000 equals the frequency. Okay, if you think you know where to go, I'd like you to pause the video and attempt that. As soon as you're ready, unpause it and I'll show you exactly how to get the answer. Okay, so all we're going to do is going to put this in our calculator. Now, if you don't know how to put standard form, I'm going to show you here. So what we do is we write the 3, okay? And then at the bottom of your calculator, you should have this button here. It says a times 10x. So we're going to press that times 10x. And what you'll see on your screen is you get just a times 10 and then a flash. So we want times 10x 8. So that's 3 times 10 to the power 8. And then we've got to divide that by 100,000. So we're going to press the fraction function. We're just going to put that over 100,000. Press equals. And we get our answer of 3 and then 3 zeros. So that gives us 3 equals the frequency, 3000. Okay. And remember to add on your units. So that's a frequency. So we want hertz. So our answer is 3000 hertz. Underline it to show the examiner you know what you're doing. Okay. There we go. So I'm going to pop some questions on the screen. Again, I will work through the first couple, and then the last ones I'm just going to leave you to try and do on your own. If you are successful, then you can check your answers on the next screen. If you need some help, then just go back over these models and try it again, and just keep going and stick with it until you're able to do these calculations. They're such an important part of the physics GCSE. And there are a lot of them. As soon as you can rearrange, and they don't get much more difficult than these, as soon as you can rearrange, you give yourself such a fantastic opportunity of getting a very high level in physics. Okay, good luck. So in this very final part of this video, we're going to look at putting together what we've learned so far. So over the last few videos, and if you can do this, it really shows a good. It shows that you've managed to link together everything that you've learned, and it means that you're really, really on track. If you can't do it, hopefully this will be able to allow you to identify where your gaps are, and you can go back and you can watch those videos. So if you got a diagram like this, you could actually figure out the speed of that wave. But we have to apply a lot of knowledge. We have to know a lot of things. So let's look at how we do it. So first off, we need to know how to label a wave. And we need to know what this wave diagram shows. Well, it shows us that the wavelength starts here. Remember, each wavelength is the distance to the next equivalent point. So up, down, back up. So there. So you've got 1, 2. So let's draw these on. 1 wavelength, 2 wavelength, and partial. You've got a half here. So we've got half a wavelength. So we've got 2.5 wavelengths. So we've got 2.5 waves in, now this is 10 seconds. Okay, now we should remember doing this from the frequency video, so we can work out the frequency. Now we don't want 10 seconds, because remember frequency is the number of waves per second. So we're going to divide this, we'll do that in a different color. We're going to divide this by itself to get to 1 second. Whatever we do to 1, we do to the other. So we're going to divide that by 10 as well. So that takes us down to 1 second, which is what we want for frequency. And 2.5 divided by 10 is 0.25. So we've got 0.25 waves in 1 second. So our frequency equals 0.25 hertz. So that's our first bit of information that we've got. The second bit of information we've got is that we can figure out the wavelength, because we've got a ruler here, and all of this is 25 centimeters. So we've got 25 centimeters equals 2.5 waves. Now we don't want 2.5 waves. We want to know what 1 wave is. So again, we're going to divide this by itself. So I'm just going to move the page up so we can see that. So we're going to divide this by 2.5 to get to 1. Whatever we do to one side, we do to the other. So we're going to divide that by 2.5. And if we do that, we end up with 2.5 divided by 2.5 is 1 wave, which is what we want because we want 1 wavelength. And 25 divided by 2.5 is 10. So 10 centimeters equals 1 wavelength. So our wavelength equals 10 centimeters. So we've got 2 pieces of information now, the frequency and the wavelength, which we can use to calculate our wave speed. So let's take it all the way back up here and let's write down what we know. So we know that the frequency equals 0.25 hertz. We know that the wavelength equals 10 centimeters, and we are trying to find the wave speed. So we don't know what that is, but we do know it's going to be in meters per second. So now we've extracted, what we need to do is we need to check the units. Frequency in hertz, yes. Wavelength in centimeters, no. That needs to be converted to meters. Remember, there are 100 centimeters in a meter. So 10 centimeters is less than 100, so this is going to be a 0 point something. So we're going to divide by 100. We're going to do 10 divided by 100. So 10, turn it on, 10 divided by 100 is going to give us 0.1. So we have 0.1 meters. Okay, get rid of this so we don't accidentally put in our equation, but just a single line so that our examiner can see what we've done. So that's now our wavelength, that's correct. And meters per second for velocity, that's correct. Okay, now I'm going to write out our formula. I want to give myself a bit of space, so let's start here. So velocity equals frequency times wavelength. Let's plug in our numbers, substitute in. V, we don't know, leave it as V. Frequency, we do know, 0.25. Leave the multiplication sign there. Wavelength, 0.1. Okay, let's have a look. Is the thing that we want, the V, the velocity, is that the subject? So is it on its own on one side of the equal sign? Yes, it is. Brilliant news. Okay, so this is ready to go. So pause the video and calculate the speed of the wave. As soon as you are ready to answer, unpause and you can follow the last part through with me. Okay, so we're just going to do this on the calculator. So 0.25 times by 0.1 equals 1/40. Press the SD button. Equals 0.025. Remember that that is V, and velocity is in meters per second. Underline it. Tell the examiner, here's my answer. Okay, so if you were able to do that from this shows that you are able to link lots and lots of the ideas that we have already done together, and it really shows that you've got a really good understanding of this wave topic so far. Okay, again, I'll leave some practice questions. I'd like you to have a go at those, and then I'll see you next time.